Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or YouTube.
Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey. Borg Warner, propulsion solutions that support a clean, energy-efficient world. And by the Michigan Economic Development Corporation.
Hello, Gary.
John, how are you?
I'm doing well. Just flew into town, just got back from that big Toyota confab in Dallas. But I can't wait for today's show because this is going to be very different from any other show that we've done.
Absolutely. We're going to have a lot of very, very innovative people on it. So let's not waste any time and get right to it.
Okay. Carmen, bring them all in. So just so the audience knows, the people here are representative of startup companies that won an innovation challenge. In fact, it's called the Global Automotive and Mobility Innovation Challenge that brings in startups that all have to do with the automotive industry as well as mobility. And these are CEOs and founders that are on here. And I'm going to ask them to give a quick 1-minute elevator pitch of what they're about, just so you and the audience can understand what their products are and what their companies are. And Katarzyna, why don't we start with you? Calling in from Poland, no less. I think this is awesome.
Yeah, I think all of you should say where you're at, because this is clearly the most international show we've ever had. And I think it's just really wonderful.
Hello, everyone. So just a few words about Coated. You probably know that when your brand new car leaves the factory, within a few first years, it's losing a lot of value because of the depreciation. It's mostly because of corrosion and rust, which actually is slowly eating your car. And at Coated, we are trying to change it. Coated was established a few years back by two PhD chemists, which know how to harness the nanoparticles, nanomaterials, and put them to the metallic coatings. And thanks to that, we are able to prevent rust and corrosion, but as well, we are able to make the smart coatings which can clean themselves or tell you when actually corrosion happens or self-repair. So actually the options are limitless. And as you mentioned, we are based in Poland. That's probably the most important things about Coated.
Okay. Chris Carde from HeyCharge. You're up.
Hi there. Yes. So hi, I'm Chris from HeyCharge, and we are in Munich, Germany. I have an American accent because I'm an American founder living in Germany. I've been here about 11 years. And years ago, I brought my first electric car home to a city center apartment here in Munich, and I couldn't install a charger. And we kind of realized the problem wasn't power. It was the cost and hassle of installing that infrastructure. We realized 36% of the world lives in apartments. But installing a charger in these building types can cost up to 6,000 euros per charger. And as EVs go mainstream, this is a social and economic justice issue. So we took a look and we realized connectivity drives about 47% of the total cost. This is including the cost of communications, back-end services, installation, and the hardware itself. And if that site is underground, like most parking garages in Germany and actually a lot of Europe, the whole thing falls apart because the user comes in with a mobile app and that has no mobile network signal. It doesn't work. So we invented something we call Secure Charge. This is our patent pending technology that eliminates the internet connection from EV chargers. So with Secure Charge, our users actually relay the data from the management platform in the cloud to our chargers using Bluetooth and their smartphones. So to conclude, we're saving that 47% in connectivity, and our technology provides a better user experience because it works underground and in low connectivity environments. We launched in Germany already. We're in the process of launching in the US for apartments and condos this summer. We also have a B2B platform, so we let our business partners white label this technology into their own products.
Ooh,
that's it.
Yeah, great. Derrick Redding, how about you?
Hi, good afternoon, Gary and John. Great to be here today. So my name is Derrick Redding. I'm CEO at Betterfrost Technologies. We're a Canadian startup, though I'm an American and I'm based in Ann Arbor. Betterfrost developed a completely new method to defrost and defog the windshield in electric vehicles with 20 times less energy than current technologies. The current HVAC system that was developed around the combustion engine is still being used. It's very inefficient, and our technology was based on decades of research from the Dartmouth College of Engineering ICE lab, where we provide high voltage pulsed electricity into the conductive layer inside of the windshields. And these new windshields that are coming out in electric vehicles already have a metal layer in it to reduce solar gain, to reduce the HVAC load for cooling in the summertime. We're using that same metal layer to also provide defrost and defog, and it's right there at the glass where you want to either get the frost off the front side or get the fog off of the inside of the glass. So in an average commute in the winter, we'll increase range of an electric vehicle by about 38 kilometers or 25 miles. And that energy savings is worth about $600 per vehicle to the OEMs that are designing these new electric vehicles.
Very good. Michael Burz, you got the stage.
All righty, gentlemen. Thanks very much for the invitation. I'm speaking to you from our development center at the Richmond Field Station near Berkeley, California. It's actually operated by University of California, Berkeley. We are or have developed a battery that is based on zinc. And this is, the first time that zinc can actually be used as a high-performance rechargeable battery. We're using technology that we worked with the United States Naval Research Laboratory. It means that for the first time, zinc can have the energy of a lithium battery, but at the cost more like lead acid, but is safer for the planet and for people. And we're here testing the battery now. But our interesting development is the way in which we're going to deliver the battery. We're actually going to do this kind of like Intel, with the Intel inside, where Intel designs computer chips and then works with computer manufacturers to develop the battery. We've developed this battery so that we can convert an existing lead acid plant from making old lead acid batteries to making high-tech nickel zinc batteries.
All great stuff. So, and Marek, we've got to hear from you too, even though we already heard from Katarzyna about what coated is. Give us a little bit more detail of exactly how your product could be used in the automotive industry.
Of course. Well, it's great to be here, first of all. John, to be sure, how can we be used in the automotive industry? We are producing additives for protection of elements and parts which go inside the car. There are so many, there can be even more than 3,000 metal coated parts in single car. So thanks to our additives, we extend their anti-corrosion properties, so they can stand longer without rust. So to be like very clear and up to the point.
So Marek, let me ask you a little bit about this. So when Katarzyna was talking about the pieces rusting, oxidizing, the normal process in the auto industry now is to dip these parts into a liquid, into a bath. And so it's a zinc bath or a nickel type bath. So does the additives that your company has developed, do they change the process, or is the process the same, but the result is different?
It's the second option that you mentioned. So the process is just the same. Since there was through so many years when people were developing the process, it has been stable for over like 20, 30 years now. So making the process different, so the electroplating process, wouldn't make it possible for us to be a part of the whole system. So we had to develop the product which is exactly perfectly matching the whole process. So we just add the additive at the same time as you add the chemistry which is needed for electroplating. So it goes together with this main chemical, and then it works to give you better options and give you better results.
So I know we're going to be jumping around a little bit here, but I think that's going to be the nature of the business. Chris, going back to HeyCharge, what makes your system low cost? And I mean, could this be applied to homes as well? Because one of the complaints about people who are considering buying an electric vehicle is they're going to have to spend money to put a charger in their home as well.
Yeah, basically, we didn't have time in the 1 minute pitch to kind of explain why all these things are necessary, but we usually focus on apartment buildings and other multi-user scenarios because those are the areas that require a smart charging infrastructure. And what I mean by that is this is an infrastructure that can identify a user, switch on for that identified user, and then communicate how much that user has consumed so they can pay for the power. And this is because in a typical parking garage, you can't really trust that someone's going to pull up and use their designated charger that's attached to their electric meter. So you kind of need that security layer. And what we, once you have that need for communications, that's where the kind of what we call the classical IoT architecture falls apart, and our system kind of comes in to make it work better, but also cost less. You ask why it costs less. It's communications. Basically, you don't pay for the communications to the site. You don't have a DSL line or a SIM card in each charger. Our backend is substantially cheaper to run because our architecture is more efficient. It's event driven. There aren't many events. So we have a very, very low cost to serve in the cloud, and we can pass that on to our users. But actually, my favorite is that the installation becomes substantially cheaper because you're saving all the steps related to communication setup. You're saving the cost of the hardware in the installation for network infrastructure. And even you're saving the process of setting up the charger because our chargers are electrically plug and play. You basically attach them to power, and our app immediately can initialize them with a secure message from our backend that is cryptographically secured. And finally, we actually make the charger itself cheaper because you get rid of the big processor, you get rid of the Wi-Fi, you get rid of Ethernet, you get rid of 3G, 4G, you get rid of RFID. So our bill of materials is lower. So it's like most good stories, it's not a simple one, but it's an elegant solution because it saves cost in many ways.
Mm-hmm. So Chris, to John's point about why not use this in the home, part of your story is that basically, if I plug in something to my house, it's just on my electric bill. You're talking about a system that actually is able to determine which individual has used the charger and bills that person appropriately. Therefore, it's for a more of a mass operation.
Yeah, we say typically multi-user site, but there is actually, there are small I say small, but it's actually a big market opportunity. There is an application for private homes. It's a little bit more common in Europe, but you have companies who basically pay for the energy used, usually traditionally gas, in a company issued car for their employees. And so as the world electrifies, those employees don't want a fuel card. They want to be able to charge at home, but still have the employer pay for that power. So that is an emerging use case for smart charging infrastructure at home. And so that's an interesting go-to-market for us as well. We have some pilots in that space.
Okay, Derrick, let's jump over to you and get into more of this. So explain more of this. I'm intrigued by this, how you pulse power through the windshield to de-ice it.
Yeah, this is my undergraduate's in physics, and so I admire physicists who have solved real problems with first principles. And the physicists who developed these theories did that. And what he found was the most, if you control the penetration depth of heat, you only need to melt the interfacial layer of ice. And that's only about 1/10 of a millimeter. So by finely tuning the power in terms of high voltage and also with the frequency, or by pulsing it, we're able to finally control the penetration. So all we're doing is melting that interfacial layer. We're not melting the entire mass of ice. And by being very energy efficient, it also happens to be very fast. So whereas most vehicles today will take, let's say, 15 to 20 minutes to defrost, we're doing it under a minute. And in some configurations, we're actually defrosting at minus 20 C, which is about 0 F, 0.5 millimeter of ice. We're defrosting in under a minute and sometimes even 40 seconds.
Wow. So what happens?
All right, Derrick, you're in Michigan. Okay. And you know that when we have our defrosters on during the winter, we also have to get out and scrape.
Yes.
Does your system eliminate the need for scraping?
Yes. Because the metal layer in the glass is evenly distributed, we don't get any hot spots or cold spots. It evenly melts the entire sheet of ice at one time, and that allows the wipers to move it off. And it doesn't matter if it's a 0.5 millimeter, or even 2 millimeters. You just need to melt that interfacial layer of ice, and then everything else will come right off with it.
It just slides right off it just slides right off the windshield then.
Yes. It's fabulous.
Two
And
millimeters
automakers are testing this. We've had 2 automakers that have already tested it, and they just come out of the test labs with huge smiles on their face, and they're getting the same results that we're getting in tests.
Where were you 4 months ago when I was out scraping my windshield?
Yeah, well, it's coming, and drivers face a lot of range anxiety with EVs, and as it gets colder, range is much worse. It drops about 20% for each 10C drop, which is about 18F, and drivers don't know this until they actually experience it. Unfortunately, maybe on their first drive in winter. And we help by reducing that energy load when it gets colder out. We extend the range considerably.
So Michael, speaking of energy, I've got to ask you, you're talking zinc here. Thomas Edison was fooling around with zinc back in the day, didn't seem to go anywhere. What's happened in the meantime?
What happened? So yes, 1901, Thomas Edison was looking at a reasonable material for battery, and a smart guy, he hit on zinc, and he frankly, Gary, he had the right material. It's the 4th most mined metal on the planet. You can get high energy and high power out of it if you do it right. It uses a water-based electrolyte, so there's no fire, and it can be recycled. But Mr. Edison, unfortunately, didn't have access to a scanning electron microscope. And I know he should have invented that as well. And the problem was he was getting dendrites. And these are tiny needle-like formations that form on charge and discharge. And most batteries get them, but zinc gets them really quickly. And so unfortunately for him, the battery was dying after a couple of dozen cycles. And with lead acid batteries having like 500 cycles, nobody felt that 25 cycles was worth it. So for decades, zinc was relegated to, disposable batteries. In fact, zinc air, is used in hearing aid batteries. So zinc has been around, but not a lot of people were using it as a rechargeable. The Navy was looking at something which could replace lead acid because it takes up too much room and it's too heavy, particularly aboard ships and subs. And they had a bad experience with lithium. They had one of their subs burn in dry dock. So lithium kind of became suspect for use aboard ships and subs and aircraft. So they started looking at zinc, and they decided to look at it in a different direction. And that's why I said Edison had the right material. He just had the right form. Typically, people use particles of zinc suspended in an electroconductive paste. And what happens is, on discharge, the zinc converts to zinc oxide, which is an insulator. And over time, more and more of the zinc gets coated and doesn't reduce back to pure zinc. And as most of your listeners will know, as you try and force more and more current through smaller and smaller pathways, you end up getting a higher resistance, which means you generate more dendrites really, really quickly. What the US Navy and we recognize that if you could make a 3-dimensional structure out of it, not just a bunch of particles, but a 3-dimensional sponge structure, just like the sponge on your kitchen sink, but at the micro scale, then that zinc oxide forms on just the outside surface of the sponge, but it leaves the inside pure zinc, which acts as a current collector. So you get no unimpeded flow of the current, therefore no dendrites, therefore a rechargeable battery. And because it's a zinc structure, it has more surface area, which now allows zinc to be used as a high performance zinc anode. And that way we can have, as I said, the energy of lithium, but at a cost more like lead acid.
Amazing. So Katarzyna, how has the auto industry, automakers or suppliers reacted to your product, Codit?
I need to say that even before we got any product and we wanted users now to have a feel if it will be interest, and actually we start to talk first with the plating shop. They told us, give us a sample, but we didn't have the sample back yet. But actually it seems that there is quite a big interest because plating industry, automotive industry, they are having a lot of pains. And to name few, there was a problem with chromium-6, which is toxic. So it was replaced with chromium-3, but chromium-3 is not so fantastic to give you nice, shiny, and robust coating as chromium-6 was. So people are trying to find something actually now to be as good as chromium-6. So actually our technology could help to make chromium-3 to be as good as chromium-6 or actually replace it with something else. Again, and actually Michael could help with this as well, because there is a problem with cadmium now, with cobalt now, because of the batteries. If we move to zinc, there will be not such a problem, but at the moment we have this problem with supply of it. And plating shops are using the baths which contain cobalt, but now there's a problem to get it. And cobalt actually improves the anti-corrosion properties. And again, we can come with our additive and actually help with shortage of cobalt. Another thing is that now and then you hear that there are, for example, the prices of nickel are getting crazy, especially recently. It happened a lot. And what we could do actually, we could take the standard nickel coating which automotive industry is using, and let's say that it's 25 micrometers thick. And by using our additive, we can reduce the thickness of the coating. So you are using less nickel, which is difficult to get, or it's not very expensive, but as well, you are getting something which is lighter, you are saving money, or you maybe prefer to make a little bit more elements because actually the plating cycle becoming shorter. So it seems that with our technology, we are able to solve a lot of pains. Hence, there is quite an interest in it.
So basically what your system does is that it allows the components to have the corrosion protection that they've historically had. It's allowed them in the cases where the coating is decorative, shiny, and looks very nice. You still have that, and yet you're able to do this by reducing the amount of the more expensive materials, nickel, chromium, so on, than is normally the case?
Exactly. And why it's happening? You know about composites. So we are taking the single metal coating and we are turning it to composite, but actually even nano-composite coating. Just because we are adding a little bit of this another phase, nanomaterial phase, we make the coatings with completely different properties. And you can make it thinner, get rid of some elements like cobalt, or reduce uses of chromium. So yeah.
Is the processing time any different? I mean, because, as you know, the auto industry is very time sensitive.
So no, as Marek mentioned, we are actually just having the bottle with our additive, pouring it to the plating bath, and that's it. The process goes as normally. And actually, as I said, since you are able to make thinner coating, you can actually reduce time of plating. So you are even make it a little bit faster.
So it stays in the bath less time.
Exactly.
Chris, back to you with HeyCharge. You mentioned that you're installing some of your charging stations in Germany. Tell us where you stand right now and what the future looks like.
Yeah, so we've actually just installed our first revenue generating sites over the last few months. As I mentioned, we are about to launch in the United States. We have a product ready to land there in the summer. Our initial go-to-market team is hired, and we're actually signing our first deals. That's pretty exciting as well. We are in the process of bringing out a higher powered device. I want to say, to kind of address our market, we need to be able to supply hardware. We started off with an ultra low cost piece of hardware we call Access Point, which is actually not an EVSE. It's basically a smart controller outside of the EVSE. It lets our users bring their own EVSE, and it gives you kind of this nice low cost proposition where an apartment building owner can easily just say yes to doing every parking space because
all right,
why not?
Wait. What's an EVSE?
Sorry, yes, electric vehicle supply equipment, or what we in Europe call a wall box.
See, I didn't ask that because I didn't want to sound dumb. Thank you, Gary.
I'm sorry.
But I am dumb, so what the hell?
No, it's not a dumb question at all. We once you're in the business, like you throw these terms around because you live and breathe them, and you sometimes forget. Sometimes it's an industry specific thing. Anyway, I'll try to wrap up my point, which is that we also are now making our own EVSE, the actual charger, the wall box. And we are doing that by embedding our technology in the form of a little PCB, printed circuit board, into a partner's charger. So we don't have to be the best at making a charger. We're sourcing a great one from our partner, but we're adding our smart layer on top of it and then packaging it into our proposition and our offer for apartment buildings. So that's basically coming out in the US right now.
Yeah, you mentioned that yours is cheaper. Can you give us an example of what a more traditional charger would cost and what yours is?
Yeah, so I think we're ready to discuss prices in Europe, which is basically the competing devices. And keep in mind, in Europe, you need to have a calibrated meter. It has to satisfy regulatory requirements, production audits, etc. Typically, EVSEs or wall boxes with that equipment cost 1,500 to 2,500 euros. Our offer will be priced substantially below 1,000.
Wow.
So this is for a charger that
by the way, I'm sorry to follow up. That's just the hardware price. So remember, there are all those other operating and installation cost reductions as well. So actually our total cost is an even better savings than that. I'm sorry, please, Gary, go ahead.
Well, so somebody is going to be able to get a unit that can be installed on the wall of an underground parking garage, and it is going to be roughly $5,000 all in dollars, and it is up to 22 kilowatt charging capability.
That's correct. Our device in Europe is 22 kilowatts for the 3-phase version, 7.4 kilowatts for the single-phase version. These are all pretty standard numbers, just based on standard wiring and circuit sizing for Europe. We are developing, like I said, a US version, which, by the way, will be actually cheaper due to the US specific requirements. I can't discuss US pricing yet because we haven't finalized it, but it's going to be, I think, even more competitive. It makes me smile to think about it. So that's good news.
Chris, so you'll make money, obviously, by selling these units. Is there any sort of additional revenue that you get?
Yeah, I mean, so typically when you've got a management platform for electric mobility, commonly referred to in the business as the back end, people are charging money per month. But again, we are beating our competition. So we are typically charging, depending on the feature set our customers require, between 5 and 10 euros per charger per month to manage that. And that is a pretty substantial savings over our competition.
Mm-hmm. So speaking of savings, Derrick, with your system, could the traditional HVAC system of an electric vehicle be vastly modified such that it just serves a cooling function and not at all a heating function, or is that still going to be necessary?
It will still be necessary for cabin heating, but the driver of the size happens to be defrosting, because it takes so much energy and so much air blowing to make that work and pass the regulations that are required to launch a vehicle. So the HVAC makers are excited about this because we can actually help them size that down. And also the center ducts can be eliminated. And so there's some space savings there. Plus those center ducts also amplify and catch a lot of the road noise and any vehicle noise. So they're actually a major source of noise, vibration, harshness. They can reduce that pathway by eliminating those center ducts. So those are some soft benefits that will come to market as our solution gets adopted.
And Gary, as you know, we just got a question from one of the viewers watching the show, from Gary Atano, who says, I've seen rear hatch glass break from defrosting in snow. Does your technology prevent that from happening?
Yeah, because the rear glass uses wire in the glass, and it's a high resistance, high heat, and they're really just they're trying to flood it with heat. And our system only, because we're just trying to control that penetration depth of the heat, the glass only gets up to 5C, which is only a couple degrees Fahrenheit. So if you touched it with your hand, it would feel warm, but it's not going to be hot, and it's not going to come anywhere near enough to getting hot enough to crack. So that's another advantage we offer is we won't stress the glass. We won't even come anywhere near close to stressing the glass because it's so energy efficient.
That's great. Hey, look, we've got to take a quick commercial break right now. Sit tight. We're going to come back. We've got a lot more questions to ask you guys.
How do Bridgestone tires stop shorter on wet roads? It's their HydroTrack technology. But you don't have to know how the science works, just where the brake is. What really matters is their Bridgestone.
The world is changing at an ever-increasing pace. No matter what the mode of transportation, there is always the need for an efficient propulsion system. And that's exactly what BorgWarner has been doing since the earliest days of the automotive industry.
The future of Michigan is extraordinarily bright. We have such incredible assets, and I think more and more we're realizing how to put those together in a way that's going to help this state really help lead the nation as we go forward.
All right, we're back. And Michael, let's come right to you then. Being able to make batteries for electric vehicles that have the performance of lithium, but at the price of lead acid is incredible. Have you been showing this to automakers? What can you tell us what their reaction has been?
So here's the interesting thing. One of my past jobs was I used to work at Nissan and ran their program to develop their race car to race at Le Mans. And so we all know how much weight.
The Delta Wing? Were you involved in that one?
I was this was Nissan Performance Technology out of Vista, California, and the MPT-9, the car that we developed. Yeah. So we can talk about that later. But the point is that weight is really, really critical for both electric vehicles as well as internal combustion engine. So our market that we're looking at is both for the internal combustion engine world as well as what we call urban electric vehicles, those electric vehicles that go less than 300 kilometers. So you referenced that we were all involved in the GAMIC award, and one of the judges from Ford asked me kind of that question of, so how does this work, for our regular cars, lead acid? And my point was, I used to drive a Ford Explorer. The battery in that weighed 30 kilos. We can give you the same energy with 3 times the life for 10 kilos. You can save 20 kilos. And most of us who have automotive backgrounds know how much Detroit will pay to save a kilo on a car for that length of time. So that's one area, is literally replacing lead acid batteries in any form on any type of vehicle. We can give you 3 times the energy of lead acid with 3 times the life for about 10 to 15% an increase in cost. So that's a major. For the electric vehicle market, we're looking, as I said, at the urban electric vehicles, things like the 2-wheelers, electric bikes, 3-wheel tuk-tuks, and delivery vehicles and urban passenger vehicles that only have to go less than 300 kilometers or about 175 to 180 miles. The short answer is, have we showed this to people? We are in the midst of that. We have a test program that we're running with the University of California, Riverside. We have people that we call an industry advisory group that we are showing this to, and there are several well-known automotive involved in that.
So Michael, it sounds like the lead acid battery replacement market might be the place that would be a sweet spot for you guys to begin with.
That's our entry point. You've got it.
Mm-hmm.
And do lead, and by the way, and how that fits is what I mentioned earlier, is that we can build the battery using existing lead acid fabrication. So I can convert a lead acid plant from building old lead acid to new high-tech zinc batteries, and effectively turning them into gigafactories with minimal capital investment.
But you mentioned that zinc is the 4th most mined metal out there. My question is wouldn't this cause there to be a greater demand for this material and perhaps even some shortages as the capability ramps up to be able to provide this material for batteries?
Yeah, so the short answer is no. It turns out I made a presentation at the International Zinc Association about 2 months ago, and I wanted them to make that very point. Zinc right now is used in 3 major areas: galvanizing, fertilizer, and medical uses. Typically they mine around 14 million tons. We could supply zinc for 1 million electric vehicles, and it would take only 4% of that. And the other reason that we like to talk about that is that, as you guys know, the material resourcing for electric vehicles right now is not only under pressure, right? The supply chain costs, Katarzyna referenced the high cost of nickel and lithium and cobalt. What we like to think of is we can help relieve that supply chain pressure because zinc is everywhere. We can use it to build those urban electric vehicles, thereby releasing some of that resource constraints that are kind of controlled by China for more high performance vehicles. And that will help lower the price of all those other commodities to both help electric vehicle adoption, either from the urban arena or from the long distance arena.
Mazak, sorry, go ahead, Gary.
No, go ahead, John.
Well, Mazak, Michael brought this up, GAMIC. This is how I got to know about all of you. You have been winners, as it were, in this innovation challenge for automotive and mobility. How did Codit get involved in this?
How we did get involved? We wanted to conquer America, so to say. So we were looking for, a place to start. So we found out that there is this kind of competition. We were actually also invited to join, and we worked a lot. We worked a lot to get there, to make our presentations as well work very well. All those hours spent during the night as well, because usually for us was night hours. So that's how we got in. And thanks to this hard work and thanks to our great product and great technology that we have been developing, we are one of the winners, and we can join your show today. So that's really great.
So let me build on John's question and ask all of you to chime in on this. Is that okay? So here are companies, you guys all have different technologies, but you all have different technologies that are different from what is being used today. What is it like to deal with automotive companies in terms of saying, hey, I've got something that's completely different. You really need to look at that. I mean, how does that all work? Anybody?
So for us, Gary, having worked at Nissan, we understand how skeptical, the automotive world can be, because they have to deliver a product to their customer which is absolutely rock solid, right? And so anything new requires them to spend some time evaluating it before it ever makes it into the automotive supply chain. And we all understand that, which is one of the reasons that, winning this was important, because it gives us that exposure and that credibility. But in our case, like I said, we formed this industry advisory group so that we can introduce this and make them part of our test program to help reduce that time to implementation. But there's a lot of hoops that we have to jump through because of their requirements around cost and safety and producibility. That's going to take us a while to do that. But luckily, I think most of us have the background to where we can answer those kind of questions and work through those test requirements.
Yeah, and like Michael, I also worked at an OEM. I had worked at Toyota, and later I worked at Johnson Controls and their automotive seating division. So I know what it takes to bring a product to market, all the testing, validation, and launching it, and all those challenges. It's also, I feel I'm very fortunate with the startup I'm working with. I have a very talented group of engineers who had been working with Ontario Technical University, where there's an automotive funded lab there, the ACE, the Automotive Center for Excellence. And they had been doing test after test after test. That was like regulatory A to B comparison, comfort tests. And so although none of them had any automotive experience, they had not only a good technology, it was very well validated. And so for me, coming in with the automotive experience, but not the having come through all the development that they had been through, this has been a nice bridge for me to say, here are the steps we have to go through. And then this comes back to the earlier question too. One of the first things I connected with the founders and they wanted me to get more involved. I said, we need to go do the GAMIC program because this will give us some good exposure. I had met David Stout almost 5 years ago when he was pitching GAMIC to the Techstars Mobility in Detroit. And I've stayed in touch with them, and it's a great program. I feel very fortunate. I look at the competition, and there's a lot of good companies that aren't here today, but these are just 4 great ones that are here today. And it was also great to be able to, we got really good exposure at SAE World Congress, and I can't say enough about the contacts that we made both at with OEMs and also tier ones.
Mm-hmm. Chris, I imagine you don't deal as much with the car companies, more with municipalities, but I'll bet they can be just as difficult to try to break through.
So it's fashionable, so I'll say I also worked for an OEM. Okay. I actually worked for Mercedes-Benz R&D in the Silicon Valley. They have a Silicon Valley R&D lab that concentrates on vehicle connectivity. So that was actually my first career position out of university. I spent 8 years there. So I'm familiar also with working with automotive. However, you are right. I was actually thinking of a way to say this. We're probably the only ones here who don't really depend on selling directly to OEMs, but the OEMs are interested in us because we are, of course, an enabler for widespread, mass electrification, mass market products. And I think the best proof point is actually the lead investor in our seed funding round, which we announced in January, was BMW iVentures. We are Munich-based. BMW is down the street from us, so it's a great fit. It was a great signal for us. We've certainly spoken with quite a few other OEMs, frequently in their CVC, their corporate venture capital divisions.
So I've got to believe, like in the situation with Codit, that here in the U.S. you probably have to deal with EPA regulations, and I don't know what the regulation is in Europe. That would be proportionate to that. Is that take up a lot of your time to show to people that what your additive is not going to have all kinds of bad consequences?
I think that we are lucky because we are mostly using the nanomaterials which are already known and used. And yeah, we have our own regulation here in Europe, and actually the nanomaterials we are using are actually obliging all the regulations or the law. So it's not so actually bad, but of course it takes a lot of time because there is a lot of paperwork. And we are having all those, I think that you may know what it is, MSDS, which is the card of material when you need to show how it influences the health, how you need to store it, if there is any interaction with something, what kind of PPE you need to use, etc., etc. So yeah, it takes some time, but I would say that it's not terrible. There are much worse things, I think, when you are in the startup than that.
Right. Katarzyna, if the auto industry goes, hey, Codit has got exactly what we need, can you scale up quickly?
I hope that we cannot scale quick enough, but in general, at the moment, we are able to make up to 1 ton of our additive per month. So if you have a client which exceeds this demand, we will be probably happy, but we are able to scale. And if something's happened that somebody's coming and saying, give us 10 tons, we could go to ton manufacturing. So there are options.
All right, so I've got to ask you, okay, how big is 1 ton of nanoparticles?
So the secret of it is that we don't sell nanoparticles in the dry form, but we put them into water, so it's easier to handle because those all metal plating bars are metal water-based. So actually, 1 ton of nanomaterials is quite a lot, to be honest. It takes 250 kilo barrels. So yeah, it's still a lot.
All right, but if you didn't have any liquid, I mean, would you be able to hold it in your hand?
Unfortunately,
really strong.
no, no. It's not like that. It will be lighter, but because it has huge surface area, actually it takes quite a lot of space still.
Okay.
So actually, I never thought how much it will take. I need to think about it.
That's great. Hey, we've got some more questions coming in from the audience here. And so, Derrick, this goes to you. David Lemieux wants to know, what if you have small cracks in your windshield? You know, is your technology going to adversely affect the windshield from that or even work?
For small like chips, it won't affect. And one of the nice things that our team has developed is ability to continually do resistance checking continuously. And so any damage to the metal layer, we can detect that and then shut the system off in that case. So chips won't have a problem, but it cracks. They can, and we can detect that once it gets to a certain size.
And Michael, we've got one for you from Chuck Grenchy. He wants to know, do the zinc-based batteries charge similarly or identically to lead acid batteries?
They're very close to lead acid batteries. Lead acid cells are about 2 volts. We're 1.65 volts. So the charging approach is very similar.
Very good.
So Chris, as you were developing your technology, to what extent did you and your colleagues go out and talk to consumers about what they were interested in versus talking to car companies? You mentioned that they're very interested in this technology so they can proliferate the sale of these vehicles. I mean, how much was their influence on what you guys developed?
I'd say we actually had to convince the industry that this was an important problem. I mean, I always find it very interesting that electric mobility, the infrastructure business, is for what is basically a new industry, is already kind of like set in the ways. So there is an existing kind of way to install chargers and a way to manage them, and everyone just keeps deploying that. And so it's kind of an uphill battle when you speak to people in the industry to convince them that something new is required. However, it's actually kind of funny because talking to the same person who might be sitting at an OEM saying, "Oh yeah, but we always do it this way." If you get them to kind of tell a story about a time they tried to charge their own car in a parking garage and didn't have internet, they're like, "Oh yeah, actually that did happen to me." And so actually, you just got to almost get the folks making decisions to kind of jump over and be a user and kind of realize, oh, actually, yeah, this kind of is a problem, and maybe we need a solution. So it's almost a kind of a game of framing, if you will.
Mm-hmm.
So yeah, and honestly, it didn't take talking to that many users to realize that this was a problem. I have to admit, we originally approached the technology as a cost reduction, a kind of a market enabler, because one of the original problems we saw was that the existing infrastructure solutions were too expensive. They didn't meet the unit economic requirements of people living in apartment buildings. It's kind of only after we built the technology and we kind of, we're like, oh, while we're at it, we'll make it work underground, did we realize actually that might be the reason people buy us, is that it really improves the user experience substantially in addition to making it cheaper.
Marek, how's it been participating in the GAMIC challenge? I mean, you talked about it, but I'm wondering, now that you've been selected as, I don't know what the right term is, a winner, a finalist, or whatever, has that helped your business? Has it increased your visibility in the marketplace?
But to be honest, that's what we are still working on. The exposure that Michael and Chris mentioned before, it's a huge plus. So this is why also we joined GAMIC, and we are working on different contacts that we gained over there as well. So we already have those contacts, and we can work on them and try to, well, I wouldn't say get deals out of them, but in the future, probably yes, that would be just great. But I think that was the most important thing that we gained from joining GAMIC at all. Maybe Katarzyna wants to tell a little bit more about it as well.
Yeah. I will add something about maybe not obvious outcome of GAMIC. So we met a lot of great people, our mentors, the organizers of the thing. But actually, we met a lot of great companies, like the guys which are here today with us, but as well others which went to the finals. And actually, we start collaboration with one of those companies, because actually we know, thanks to GAMIC, we learned what we are doing, and we see that actually we can collaborate. So we just this week, we now set the details of the project which will be running together. So yeah, there is a lot of positives, not only getting visibility, but as well having new collaborations.
So is this collaboration in terms of, okay, this is the approach that you need to take to get into the market, or is this collaboration on a more technical level in terms of somebody's making a process that your material could be used with?
Actually, it's both. And actually, there is a third aspect as well. So we are working on the technical side, because actually the company, I don't know if I should say it loud, which one it was, so I maybe keep it secret, but actually they needed a coating to have the technology embedded in this coating, because we not only know about additives, but we know about metallic coatings as well. So they needed this expertise. But as well, going to the market, and they have a lot of contacts in US, which we don't have so much, so they could help us with that. And the third aspect is that actually we can apply together for financing. So yeah, there is multi-angle collaboration going on.
Chris, how did you find out about GAMIC?
To be honest, I'm pretty sure I got an email saying you should apply to GAMIC. And I said, oh, what's GAMIC?
Go figure.
We started the process and said, oh, this actually looks pretty useful. We have some ambitions to launch in the United States. Maybe this would be a great way to elevate our visibility. And as we see with, our participation on shows like this, it's absolutely doing what we hoped. So that's wonderful.
That's excellent.
And
Michael, you knew about GAMIC ahead of time, or how did you get involved?
No, we're with Chris. As a startup, you're part of all kinds of accelerators and incubators and so on. And there's one that we were part of called F6, and they tend to collate all these kind of opportunities, and then they send them out to people. So like Chris, we got this email from F6 that said, hey, what you're doing kind of fits in. You should apply for this. And candidly, I looked at it and I said, oh my gosh, another competition. And I said, oh, okay, I'll fill this in. And it's automotive. So I'm an automotive guy, so that ought to work. And then frankly, we sent it in thinking nothing's going to happen, because, you're busy doing your own work. And suddenly this thing pops up and says, congratulations, you're now in the quarterfinals. And it was like, holy mackerel. So yeah, that led then to here.
And it's been a good experience for Enzinc?
Awesome. Just been awesome. Very good.
Yeah.
All right. So I got to wonder that, okay, we're talking about the auto industry and we're making it sound like it's very monolithic and it's a big thing and everybody behaves the same. But, as you know, there are the traditional auto companies and there are the startup auto companies. As you all are talking to companies about your technology, do you see a greater receptivity from either side, or is this just a good time in the auto industry monolithically where they all want new technology?
For us, they all want it. And I think what's interesting about what we're doing is we're not part of the powertrain that, which is where all the focus is to extend the range, lower the battery cost, because there's that large gap between EVs and combustion engines. We're really working on the secondary technologies like the HVAC, which is a very old architecture. When we explain what we're doing, whether it's an OEM or the tier ones, they're like, this is brilliant. This is so much better than the way we're doing it. This makes a lot of sense. So I've actually been very impressed with the speed that we're moving through things, especially with the more mature, established players. Having been in the industry for more than 2 decades, I've been very, very impressed with that aspect of what we've been doing.
On our side, Gary, it's been the smaller, more agile that have been more readily to adapt it because they need a differentiator. In fact, one company we're working with is in India, and so they need something for 2 reasons. Number one, for cost, and the other is, as you probably know, India is moving toward electrification very strongly, particularly around urban mobility. And many of the companies are Chinese companies coming in, and India wants to increase their domestic manufacture of batteries. And so this particular company we're working with, which is building an urban electric vehicle, wants to make sure that we're working with Indian battery companies so that they can use both a domestically produced battery as well as a safer, cheaper battery for their market. So we find them moving quicker because of their market demands, whereas the established automotive firms, of course, have a huge brand to protect and certain processes that they need to follow before they allow something like our type of battery into their inventory. So we're kind of working in two speeds, if you will. One is at the speed of a startup, and the other is at the speed of an established automotive firm.
Mark, how about with Carde? More of a response from traditional automakers or from the startups?
First of all, we are absolute rookies in the automotive industry, so we don't have so much experience as you guys have, like so many years in OEMs. So for us, it's absolutely a new experience, like how we should approach this kind of companies. And but we see more or less now, after those several years, that it goes like you say, the traditional ones need a lot of expertise. They need a lot of testing. They need to be sure that what we do and what we have to offer just fits into their needs and it fits to a whole process they are doing, and it takes a lot of time. And to be honest, we don't have experience with companies like the startup companies in the automotive, except what Katarzyna mentioned. But like if we think about the OEMs or the companies that are doing car parts or cars in general, which are smaller ones, so we don't have experience in that at the moment as well. Maybe it's a thing we should look at more closely, because we could maybe get a faster feedback from them and just to start the cooperation faster.
Very good. Look, we're at the top of the hour here. We should probably wrap this up, but I want to thank you all. This has been fascinating. I think we could have done a show individually on each of you and your companies. And I'm sure we're going to have follow-up on this too, because the technologies you're bringing to the market are very impressive. And my hat's off to GAMIC for identifying your companies and what you're doing. And I only learned about GAMIC a few weeks ago. So it's been fascinating for me.
You didn't get this email from F6.
That's right. So folks, thanks very much. And Gary, I don't know if you got a closing thought too.
No, I was going to say that what I find to be interesting about this is that, you're all doing different things that are very essential. I mean, and I think a lot of this technology, again, going back to this monolithic thing of the auto industry, and many people just look at the thing as being done. I mean, so for Carde doing the electroplating processes, which is very foreign to many people. I mean, very essential. And I mean, that's fascinating to see. Batteries, have been around for like ever. And you guys at Enzinc are looking at a different approach to it. Derrick, your company, in terms of those of us who live in the Midwest, really appreciate something like what you're up to. And I got to quickly ask, you said the Dartmouth Ice Lab, they study ice there?
Yeah.
Wow.
There's another show.
Yeah.
And finally, Chris, I mean, there are more people that I hear who are struggling with charging than you perhaps even can believe. And I know that that a lot of people have expressed that to you. And so, the development of this is just a great thing. So to all of you, my hat's off, where I'd be wearing a hat.
Great. Thank you so much for having us.
Thank you very much.
Our pleasure.
Thank you,
Yeah.
guys.
Thanks, everybody.
Thank you a lot.
Thank you.
Bye-bye.
Take care.
Bye.
Bye now.
Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey. Borg Warner, propulsion solutions that support a clean, energy-efficient world. And by the Michigan Economic Development Corporation.
Visit our website, Autoline.tv, where you can watch us live Thursday afternoons. Get your daily fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.